And please welcome our co-host and next speaker, Markus Baum, Senior Partner of Roland Berger.
Thank you, Oliver, and sorry for disturbing the funny part of the Congress, the lunch and the networking. I would like to talk about the things that we as a company and myself have realized the last 2 years in many projects for the several vehicle manufacturers on the passenger car side as well as on the OEM side. Here we go. 4 things that I would like to discuss a little bit. Okay, what are the frameworks in which we need to work in, comparing the past to the next years, at least our view. Then looking a little bit more ahead, what needs to happen and should happen and will happen with most of the OEMs until the end of the decade. What are the implications out of these decisions that are made now? And then one negative aspect that we realized in our work for several OEMs. They all aim to do everything on their own. And if you look to the cost structure, this cannot be a good solution. So I would very much encourage everybody to have something against it. We're monitoring the market for automotive software very closely since 7-8 years. And looking at the last years, it had been paradise for software development. I want to have something, you will get the money. There's a problem, you get people, you get money, was not a problem. Consequence, the thing become more expensive every single year. The last year we saw in average across all OEMs between 10 and 15% budget increase for software development. Fantastic times. But when looking possible that are just the R&D spend of all the players, and you see they only see one direction, especially for the Germans. It's crazy what they spend for software development and development in general. A little bit more cautious, the Asians, with the only exception BYD. But BYD, they kept basically their R&D share constant. They just grew so badly that they could afford to do so. Welcome to reality. This time is over. We will not see the next years that the budget can increase with the same speed as we have seen before. But we need to do the change, the transformation. We need to do the transformation with less money than planned the years before. And this is true across all the Western players. What's the ambition that they all have? I mean, we talked to basically all the OEMs the last 18 months. Summary of the vision. We want to have a central zonal architecture, having 2-3 high-performance computers, accompanied by 3 to 4 zonal computers that do decentralized power distribution, channel communication, and do a little bit of consolidation of ECUs. And there will be a very high level of hardware-software abstraction, so that you can develop the software to a high degree independent from the hardware underneath. It will not be possible in all areas, even if there are single players out there that say, okay, I have a solution where I can abstract the software from the hardware for the entire vehicle. Most of the OEMs have doubt that this will work out. Reasons to do so? It will be more cost efficient. Engineering will, over lifetime, cheaper. Yes, you will have a peak in the beginning, but over lifetime, the one-time efforts will be significantly lower. Due to the new EE architecture, you will have significant savings or can achieve significant savings on the material cost side, cheaper wiring harness, less ECUs. And especially for the German OEMs, the last thing is important. Faster time to market. They realized if they stick to their old processes, they will never ever be competitive with the Chinese. But the thing is massive. That's the reason why we aim toward the very right-hand part, coming from the left-hand side. So that's the reason why we see a more gradual involvement. Okay, let's do the intermediate step with having a domain consolidation, taking out a few ECUs by doing this, and then in the next generation, do this step. This has a lot of advantages in terms of what needs to change. I mean, the changes on the central zonal approach with having one big software stack on the HPCs is a major one. So there are good reasons to do this intermediate step. And following up on the discussion that we had just a few minutes ago, looking at the Chinese, you see they are moving rather quickly and following the example that Tesla set already in 2017. But even the French and the North American OEMs are more progressive than our Germans. If you look at the timeline, they are about to change now towards a domain-centralized approach. VW is there. Mercedes and BMW will follow the next year. The next step, the next iteration, will take at least until the end of the decade. And even there's a huge span. The Chinese, on the other hand, you see very progressive, very early on the final solution, central zonal with a hardware abstraction. Yes, there are a few that say, okay, I need to do smaller steps, but even they iterate faster than the Germans. This all is coming with quite a hefty price ticket. That's from the interviews that we did, just one result. How much does it cost an OEM to do the transition? Coming from 1.2 billion US dollars or euros in software development cost, mid of the last decade, now to roughly 3 billion, so basically doubling the engineering efforts. That's the consequence of saying, okay, I want to do this step. Coming back to the things that we discussed at the beginning, you need to do now this investment in a time where the money isn't that easily available. This US OEM did, from my point of view, a quite interesting approach. The lower part, they kept the old legacy software running and spent quite a significant amount of money. And then they afford themselves, since 2016, to have a very parallel team with own processes, with an own organization, with an own budget, to bring SDV to life. But you see, doubling the engineering efforts. In parallel, the investments that you need to do on the tool chain, on cybersecurity and cloud services. Cloud services, it's not to run the cloud, just to develop the tools for the cloud. It's quite a massive investment. From all our findings, the thing that me personally found interesting, everybody's saying the commercial vehicle guys, okay, laggards, they do everything way later. If you look at the timelines, boy, they are quicker than the past car OEMs. So it might be a good way for all the people in the past car industry to look at what they have done, and they have done it with significantly less people and significantly less money. Speaking about the amount of change, from our point of view, there are a few things that you need to do. I really say need to do. First, you need to change the organization. Have at least, on a project base, one software organization that has cross-domain responsibility, cross-functional responsibility, end-to-end responsibility, and responsibility over lifetime. The responsibility does not end at SOP. It goes on. You need to develop the HR tools. You need to hire new talent to build up new competencies. You need to develop a career path for those talents. You cannot stick them into the automotive pattern. That will not work. You will not keep the talent that you have once acquired. That's the organizational side. But also on the process side, there are major changes required. The most important thing is take software out of the usual product creation process. It's a different thing. It needs to be independent. It needs to be planned completely independent. Then there needs to be some synchronization. But you cannot do it as part of the overall vehicle development process. You need to have a system engineering approach, otherwise you cannot control the complexity. You need to have agile processes with all the DevOps that's required. And the thing, Matthias, that you presented at the beginning, you need to measure performance. Otherwise, you cannot control this thing. Quickly on the organization, the easiest way is to say, like Mercedes did, do a project organization. Have somebody responsible for the entire thing, but keep a big part of the people within the existing organization. And just on a project base, try to centralize them. The more radical, and in the long term, the more viable solution very likely is the thing that VW did with Carriot, that Tesla did from the beginning, Volvo is doing, saying, have one organization responsible for all software and most of the electronic development. Knowing that this change is really, really, really massive. This is not a process that happens like this. It's a process that takes many years. I said, okay, I would also talk about one negative aspect that I have realized in all our work around SDV movement. If we map different OEMs on how advanced are they with regard to SDV approach, how much functionality do they have, how much organization advancement do they have, and try to cluster them. And then look on the other dimension, how much software do they in-house? And you see a very high correlation. As more advanced the OEM is, as more software they tend to develop in-house. Would be okay if this would be a static picture. The problem is, everybody wants to be on the upper corner. So that means everybody is trying to build up resources to develop a very high share of software in-house. This made sense for Tesla, saying I have something unique where nobody on the outside is available to help me. But now companies like BMW, Mercedes saying, hey, I want to do 70–80% of my software in-house as an ambition. I have doubts if this is commercially wise the best solution. The problems that we very often hear is, I want to have the IP rights, I want to understand, and I want to optimize the systems. The easiest way to do is if I do everything in-house, not knowing or not really thinking through the consequences of having 10, 15,000 people in software development. And there are a few examples out on the market that show from the coordination of such a big software unit, it's not the easiest thing to do. And one solution that we believe is you need to have different approaches. One thing could be or should be open source, taking away a lot of the constraints or considerations of the OEM, saying, I don't know what's in it, I don't own the IP. Open standards will also or should also contribute, and there will also be new models. I mean, Jeff is here saying having a new platform to really try to commercialize automotive software in order to make the entire thing work without blowing the entire engineering budget required. Thank you very much. My 50 minutes on what we see will happen and should happen the next years on software development. Any questions, comments?
Thank you very much for your insights, Robert Fye from Synopsys. I know Carriot quite well, and I've made some own analysis about how Tesla is doing it.
Yeah.
And what I recognize is that Tesla has pretty less people in the development according or in comparison to VW Group. How could you explain that with your graphics and?
You're absolutely right. Depending on the people that you're asking, they have a fifth or a third of the people that compare to Carriot. One reason for sure is that they have the right processes, that they have the right culture, that they have the right talent. The other, not to underestimated part is the complexity. Tesla is a one-product company. They have one E architecture within 4 generations. Looking at the VW Group, it starts from the Polo, or the up in the past, up to a Porsche and an A8. So the complexity of the software is there. And I discussed with many of my OEM clients to say, okay, for this variety of vehicle requirements, to have one EE architecture is close to be impossible. So they did a lot of things right, but they also had Tesla did a lot of things right, but they also had way easier framework conditions to innovate into this thing. I mean, for a premium OEM, like BMW, Mercedes, everybody said, okay, we need to have at least 2 parallel EE architectures, otherwise the thing will be so complex and there will need to be so many different branches, or the entry-level vehicles will have such an expensive EE architecture that the customer is not willing to pay for it.
Are there?
One short question. Thank you for that really nice presentation. Actually, the software-defined vehicle should be a framework where we can easily work together.
Yeah.
And now your analysis revealed that these companies who are far ahead with software-defined vehicles do everything in-house. So what's wrong here in the game?
I mean, we try to get over with Oliver and Seerene to test out the idea of having software expert boot camps with executives in the automotive space. There was no interest. And really, in the meantime, I believe this lack of experience is a major problem. I mean, you cannot justify such a thing. You need to believe in things. And everybody who has done radical changes believed and stood for it. I mean, you cannot argue or argument a thing like a CARIAD. You need to believe in it. So I fully believe into the concept of a CARIAD. The same thing true with the changes within Mercedes. There had been key persons believing in this transition and making it happen. Otherwise, it will not. And we need to, as a community, we need to say, okay, software works completely different than hardware. And by repeating it constantly, maybe there will be some willingness to open up and to really try to understand what are the different requirements.
There's 2 more questions.
Yeah, just information. We analyzed about 3,000 job descriptions of Tesla worldwide about engineering in the engineering department, and to us it didn't look like they have so far away development process that we have. I don't know what's different, but it has been, as I said, 3,000 using the same tools as we do, except ours.
Hello. So Jeff from SDverse,
Yeah.
Detroit, Michigan. Just a question about where the ecosystem in purchasing is moving. You talk about the engineering. Maybe you can shed some light on the European purchasing departments and how they're seeing as they purchase more software. What are they doing to adapt to this new normal?
First, the most important thing is the software purchasing should be part of a software unit, not be in the purchasing department. And if you look into the things that the Mercedes has done, that the VW has done, they have already implemented this one. And as I said, end-to-end responsibility, ideally there are part of this team responsible for a certain part of software that's not centralized, not somehow away, but it's really a crucial part of the software engineering part. And then you can also way easier coordinate with co-development, the large-scale agile teams with third parties, suppliers, software vendors, so that we really split up the old structure, becoming more part of smaller agile teams. Any other questions?
Yes, I have one question, Evgeny from Volkswagen Group. You showed the graph that Volkswagen tried to catch up to Tesla, in-house development. Do you think it makes sense to do that, or do you think it's a good mix between in-house development and sourcing? So what do you see the break-even point? Because when you have to accelerate from 20 to 80, it's a very far way to go. So maybe it's a mix between both. Or do you see
I'm not an advocate for saying to do everything in-house. It makes cost-wise no sense. You redevelop something that's already there. And by reusing it, it will always be cheaper. At the moment, there's a big but. If you transport one functionality from one EE architecture to a next customer EE architecture, 60-70% of the costs occur for minor engineering changes and for an enormous validation process. If you have some kind of standardization and middleware that is similar from OEM A to B to C, this model perfectly works. But there's some willingness from the OEM side. I'm open to say the OS, it's not differentiating. I'm willing, as CT Tech, let's agree on one standard that everybody can accept. I mean, as soon as the fundamentals are there, cross OEM middleware or hardware abstraction layer, then go for only the differentiating part for you as a brand and purchase the other stuff. Thank you very much.
Very much for this dense and smart presentation, Markus.